Okay, I'm going to start explaining you merge sort. Merge sort is another algorithm to perform sorting on arrays. Okay, now this involves two arrays. Say, for example, this is our first array and this is our second array, array 1 and array 2, A1 and A2. The first array has four elements and the second array has three, four, say five and six elements. Okay, so the size over here is 1, 2, 3, 4. The size over here is 6. Now, here we have all integer elements. So let me just enter any values in the first array. Let the values be 2, 11, 35, 51. Okay, the second array has again elements which are sorted. Okay, let me start with 1. Let me have 30. Then I have 46, then 63, 71, and say 90. Okay. Now, looking at the numbers over here, looking at the data which is there filled up in array 1 and array 2, you must have followed that the condition which is required for merge sort is that the two given arrays should be sorted. Okay, the given arrays should have been sorted, then only we can perform their merge sort. So now our task is, what we need to do over here is, we have to merge these two arrays and get this resultant final array, which will be sorted. Okay, so this will be merge sort. All right, for this now we are going to consider pointers. Let's take a pointer I, which will have the value from this particular array. And let's have a pointer j, which will have the values from this particular array. And finally, I have the pointer k, which will be involved for designing this particular resultant array after merging. Okay, now here we have four elements and here we have six elements. So that means in total, the resultant has 10 elements. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, just imagine it's only this much. All right, so let's begin the process of merging. Now, first of all, we have to compare the first value of A1 array and the first value of A2 array. So whichever pointer, now here this pointer is pointing to this particular location, and in the beginning j over here is pointing to this particular location. The resultant that I have to place the values over here, k pointer is pointing to this particular location. So this will be the result. Okay. So the first process will be comparing the first elements of the two arrays and selecting the minimum one, the lesser one. So when 2 compared with 1, definitely we can see that 1 is less than 2. So what will happen? 1 belongs to the second array, A2. So 1 will be picked up from here and written as the answer. 1 will be picked up and written as the answer over here. So we have a 1 over here. Alright, the moment we get a 1 over here, since 1 has been selected from array 2, this pointer j will now move to the next location. Alright, nothing will happen to the first array since this was not selected to reach the final destination. Coming on to the final array, this pointer will also move ahead because now we want to store value in this position. Got it? So 1 was compared with 2, 1 was less than 2, so 1 came over here in the final array. The pointer position, now this is k, now this is the new j, and this is the previous I, this will become the new I also. Now again the next number to be compared is this number 30. So from this particular array A2, now we are going to compare 30 with 2 because this has not shifted. Okay, so we have to compare 30 with 2. And now we can see that 2 is less than 30. So 2 will reach the final position. Okay, now in this example, in this particular case at present, since this was selected from A1, the value was selected, so A1 pointer will move ahead to this value. This will remain as it is. The answer pointer will also move ahead to make space for the next element. Now the next element to be compared will be 11 with 30. So 11 is less than 30, so 11 will reach the final place. Since it was selected from A1, so A1 pointer I will move ahead to 35. This will remain as it is. So next comparison will be between 35 and 30. Okay, so 30 is less than 35. So now 30, that is from this. Okay, after this 11, the pointer will move ahead to make space. So now 30 is less than 35. So 30 will reach here and this pointer will move ahead for the next number. This will remain as it is. This pointer will move ahead to make space for the next element. Now the next comparison is going to be between 35 and 46. So now 35 is less than 46. So we have 35 over here since this was selected from A1. So the pointer will shift ahead. And now the next comparison will be between 51 and 46. 46 is lesser number. So next we will have, this was shifted over here. Next number is 46 and then again making space for the next number. Since 46 was selected, so now the pointer over here will move ahead to have the next selection as 63. This remains as it is. 51 selected compared with 63. So definitely 51 will shift to the final result. The final pointer will move ahead. Now, since over here the array is over, we don't have any further elements. So now the algorithm of merge sort says that whatever elements or whichever elements of the other array are left. In this example, we have 63, 71, and 90. They are simply picked up one after the other and placed in the resultant array. Okay, so this is finally the array which we are getting over here. This is our finally merged and sorted array. So merge sorting has been performed and this is our final result. I hope you followed this. Thank you.